This video will show you how to use a calculator to work the formulas in section 10.3. So the first formula I'm going to work on is the compound interest formula, which is shown right here. And here's an example. We invest $7,000 for 3 years at 5.5% interest compounded monthly. Find the total amount accumulated and the interest earned. So I took my formula and I put in the numbers from the problem. Now I'm going to pull up my calculator. And this is just simply a scientific calculator on the computer. So when you use a formula like this, you're going to start right here. So I'm going to go ahead and I'm going to put in 0.055 divided by 12 equals, and then I need to add 1, so I'm going to put plus 1 equals. I need to raise it now to the exponent. In this case, it's 12 times 3, or 36. Here's my exponent key on this calculator, so I'm going to click on it, put in the exponent, 36. And then finally, I'm going to multiply by the principal that I invested, which is $7,000. So my total amount accumulated is $8,252.64. And there's my answer. And then to find the interest earned, we simply take the amount we invested, $7,000, and subtract it from the accumulated amount, and we get an interest earned of $1252.64. All right, the second formula in this section is the effective annual yield formula. And here it is here. It's basically you take $1 and invest it for 1 year at the interest rate and the compounding given in the problem. Calculate this portion and then subtract 1 to get back to an interest rate. So let's work an example. Determine the APY for $1 invested at 4.75% compounded monthly. So here's my formula. Monthly means 12 for N. And I'm going to pull up my calculator again. And again, I'm going to start right here. 0.0475 divided by 12, add 1, and then I'm going to raise it to the exponent of 12, and then I'm going to subtract 1. So the rate is 0.0485. And if I want to go ahead and change that over to a percent, I simply multiply it by 100 or move the decimal 2 places to the right. So the effective yield of 4.75% compounded monthly is 4.85. The last formula in this section is the present value formula. This tells us how much do we invest now in order to accumulate a certain amount given the interest rate R and the compounding periods N and the number of years. So let's work an example. We have $26,000 we want to save in 15 years. How much do we need to invest now in a CD that pays 2% quarterly to reach the goal? So again, I took my formula, put in my values. I'm going to pull out my calculator. Again, I'm going to start down here in the denominator. 0.02 divided by 4 plus 1. And I'm going to raise it, in this case, 4 times 15 is 60. All right, now in this calculator here, it has a memory. So if I go ahead and I hit memory S, it will store that number in the memory. And you notice it puts a little M up here. Now, if you're not comfortable doing that, what I did right below here is I went ahead and I wrote down the 26,000 and then that number for the denominator. But again, I'm not going to be able to keep all the decimal places, so I might get a little bit of rounding error if I don't keep this number in my calculator. So now I'm going to go back and put the 26,000 in. And again, in my calculator, the memory is pulled up by memory R, which means memory recall. And then I'm going to hit equal. Oh, I made a mistake. Let's try it again. 26,000, I think I multiplied instead of divided. Divided by memory recall. There we go. So I need to invest now $19,275.68 in order to accumulate $26,000 in 15 years at 2% interest compounded quarterly. So hopefully this will help you with your calculator when you're working on the formulas that we use in section 10.3.